Alright, parallelogram. So, a parallelogram is a polygon. So, it's all the three things before. It's a quadrilateral. But what makes it different is two really, really important things that sometimes people forget that are way too important to forget. So, parallelogram, it has the characteristics of the polygon. So, a short way of saying it, it's a quadrilateral. So when I say it's a quadrilateral, it has to have four sides. It has to be a polygon. The one thing that makes it different is that it has two pairs of opposite and, opposite parallel, I got ahead of myself, and congruent sides. So because it's a polygon, it has to be 2D, it has to be straight, and it has to be closed. Because it's a quadrilateral, it has to have four sides. But what makes it different, special, unique, like what sets it apart from just being a regular quadrilateral or just being a regular polygon, is that this part right here. Two pairs of opposite, parallel, and congruent sides. So just like you took a pre-test today, you'll have to take a test over the different shapes, and you'll have to start thinking, okay, what makes a parallelogram different than a polygon? A parallelogram has everything here. It has to be 2D, closed, straight, four sides, two pairs of opposite, parallel, and congruent sides. Polygon just has this, quadrilateral has this, and the four sides. Parallelogram has all of this. So, because now you're in high school geometry, you can't just draw a parallelogram just like how you think it looks. It has to be labeled, and I'll show you what that looks like in just a minute. I'll give everybody a chance, and then we'll talk about the examples and the non-examples. Since it's hard to always get out like a measuring stick and then and a protractor to measure the angles and the sides, what we do is we just label them. So I'll show you how we label something to show it's parallel and to show it's congruent. Because like I said, it's hard to make them all perfect with the ladder and a protractor every single time you have to do that. So I'll show you how we do that without having to actually measure it out. So to draw a parallelogram, this would be the correct thing to draw. It has to be parallel and congruent. So if these sides, these two sides are parallel, I draw a triangle to show it's parallel. If they have the same number, that tells me that they're parallel. Those two are parallel. Oh, I know you can't see that. Let me try to zoom in. If you don't come up to the top, I'll go back up. Maybe my exposure. No, it looks fine. And then these two have to be parallel, so I draw two triangles here. And that shows me, because they're the same amount of triangles, that those two are parallel. Okay? That's how I show it's parallel. Now, to show it's congruent, it's like what we did with isosceles. For isosceles, we put tallies. Do you remember putting tallies? So those have two, so that means that those two are congruent, and then these two are congruent. Alright, so again, the triangles tell you if they're parallel, and then the little tallies mean that they're congruent. So for you to draw it to where another mathematician could know what kind of shape it is, you have to put this on there. Okay? So a non-example would be something like a trapezoid, where you only have one pair. Okay? I'm trying to think of another one. We're going to talk about a kite later. and a kite, none of them are parallel. So that's what would make those non-examples. What's another one that we did? Yeah, a triangle would definitely be a non-example because it's not even a quadrilateral. It's not even kind of close. But yeah, it would be a non-example. Yes.